We will proceed in pseudo multivariable calculus. Pseudo multivariable calculus in which we are proceeding the discussion. If someone cracks pseudo multivariable calculus, means he is pioneer in mathematics. That is for sure. And pseudo mathematics calculus, it has wings not only in the integral calculus or differential calculus. It has wings. It has wings in 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 differential equation. There are mainly three parts that we will see. One is integral calculus in calculus, one is differential calculus, and one is differential equation. So we will see that among these three parts, we all three parts. If someone is master in pseudo multivariable calculus, then he is master everywhere in mathematics. Pseudo multivariable calculus, how we can start tackling a mathematics problem, how we can start tackling a mathematics problem from a simple multiplication division like that, and then slowly we will move into differential equation, integral calculus, differential calculus. So that is the idea. Okay, in the past video, means we have already talked about calculating the surface area of the sphere, and surface area of the sphere is surface area vector of a sphere. Calculate the magnitude of it. Okay, what is the surface area? What is the surface? What is the surface area of? What is the surface area of this rectangle? What is surface area of this rectangle? So one answer to this problem. Okay, so we have already calculated surface area of a sphere. Okay, we have already calculated surface area of a sphere. Okay, surface area of a rectangular shape. What is surface area of this rectangular shape? So that is in the question. What is surface area of this rectangular shape? Surface area of this rectangular shape is, I have to find surface area vector. Surface area vector, and calculating the magnitude of surface area vector will give would give the surface area of a surface. What is the length of this curve? What is the length of this curve? What is length of this curve? Length of this curve is this is a curve line. Length of this curve is a vector representation of this curve, and calculating the magnitude of vector representation of this curve is the length of this curve. What is the length of this line? Vector representation of this line, and then calculating the magnitude of it will give the length of the line. What is length of this curve? Calculating the vector representation of this curve, and then calculating the magnitude of the vector will give the length of this line. Are you kidding? Calculating length of a curve line is impossible. There can be very tedious. Consider there is sinusoidal curve is there. This is sinusoidal curve. This is sinusoidal curve. What is the length of this curve from 0 to 2 pi? What is length of this curve? Okay, you are saying that calculating the vector representation of this curve and calculating the magnitude will give the length. Sinusoidal is so complex curve. How I can calculate the length of this curve? You can try. No one is stopping you. Calculate the vector representation of this curve and calculate the magnitude of it. You will get the length of the curve. Okay, what is the surface area? In similar fashion, what is the surface area? Surface area is vector representation of the surface. Calculating the magnitude of that vector representation will give the surface area of a surface. Are you kidding? Okay, surface area of this would be simple length into breadth. But surface area of this kind of a sphere, consider this is a sphere. Okay, it looks like some satellite of Mars, Phobos or Deimos. Okay, it is moving like this. Okay, surface area of this sphere, if I calculate the surface area vector is perpendicular to the surface. Line vector, curve vector is along the line. Make sense? If I say that vector, what is vector representation of this line? That the vector will be along the line. What is vector representation of this line? Vector will be along the line. Okay. What is vector representation of this surface? Hop. What what is vector representation of this surface? Vector representation of this surface is perpendicular to the surface. Make sense? It is different. Calculate the vector representation of a surface. Calculate its magnitude. You will get the surface area. Amazing, mind blowing, thrilling, right? Can someone believe this? Just calculate the surface vector and magnitude. You will get surface area. Any surface, any surface. Okay. If I calculate the if I calculate the vector representation of the surface, surface vector is perpendicular to the surface always. If I calculate vector representation of the surface, then it will give the surface area. It will give the surface area. Calculate the vector representation of the surface and then calculate its magnitude. It will give the surface area. This is what we have seen. How to calculate vector representation of surface, that is an art. How to calculate the length vector representation of a curve, that is an art. But everywhere y and x is there. Z, X and Y is there in 3D, and in 2D Y and X is there. Y and X are different for different kind of curve in 2D, and in 3D Z to XY relationship will be different for different kind of 3D. There is the catch. And the area vector will come in the term of z, x and y, and in that sense relationship between z, x and y will be different for different surface, and in that sense it will be different. If it is a paraboloid, it looks like a paraboloid, I believe so. Okay, this looks like also a paraboloid. For paraboloid, the 3D equation is z equal to x square plus y square. For a cone, z equal to square root of x square plus y square, or height by height of the cone by radius, height by radius into square root of x square plus y square, that is the z. For paraboloid, z equal to x square plus y square. For sphere, z equal to square root of a square minus x square minus y square. Here it is different. What is the area vector? We calculated the area vector at any area. What is the area vector? We bisected it in xz plane and we bisected in yz plane of a sphere. Take a sphere, take any point on the sphere, and at that point make a cut in xz plane, and that point make a cut in yz plane. Xz plane cut will bring a circle. XZ plane cut will bring a circle. Hop. If it is a sphere, XZ plane cut will give a circle. YZ plane cut will give a circle. What is the vector representation of this XZ plane circle? And what is vector representation of YZ plane circle? Take a cross product of these two. It will give you the surface vector. Please watch previous video for the detail. So surface vector in xz plane make a cut and calculate the curve length. Calculate the it will make a circular curve. Calculate the Consider we took a point on the sphere as a point and then we made a cut. Consider that point is this. And then I made cut in YZ plane also. Consider this point is here on my side. Okay, whatever it is. Now I have this point is x comma y comma z. And if I move in YZ plane, again this point is x comma y comma z. If I take in XZ plane, this point is, if I draw a position vector, if I take a kind of from origin, if I draw in vector form, then it is xi plus yj plus zk. In that sense, if I take out x, it becomes I plus y by xj plus z by xk into x. And y I took as y by x and z by x, because for a curve if I take this as x axis, this as z axis, this is y axis, where this is in xz plane, where everywhere y is same, x is varying and z is varying. In that sense, if I take like so, then everywhere z by x is different. Makes sense? If this is a circle in xz plane, and this is center, and this is x-axis, this is z-axis. Anywhere, if I take a point z here and x here, z by x, if I calculate, then I take any point here, z here and x here. Z by x, everywhere it is different. If like that, then I have to denote, if this is a point called x comma y comma z, from center, this vector will be xi plus yj plus zk. Typically in two dimension, if I have a vector representation of a curve, then I can calculate the magnitude and it will give the length of the curve, that is xi plus yj plus zk. If I please watch previous video. So xi plus yj plus zk, then calculating this magnitude x square plus y square plus z square, square root will give the length of the curve. Okay, but we see, if it is this curve is a straight line and this point is x comma y comma z and this is origin, then indeed xi plus yj plus zk, calculating its magnitude will give the length of the line. But if it is not a straight line and it is a curve, calculating the length of this, here z by x, z by x, z by x is different. Then I have to represent this vector xi plus yj plus zk in terms of z by x, so that we will take care of the variable z by x. Now I take out x and it becomes I plus y by xj plus z by xk into x. Y by x is 0 because it is xz plane, and y is not variable if I vary in x. Y is everywhere constant. So y by x is 0. I can take it out. It becomes I plus z by xk into x. Division becomes differentiation and multiplication becomes integral calculus. Now it becomes I plus dz by dxk into dx. Same, I had made a cut in yz plane. There it will become x by yi plus j plus z by yk and into y. Now in yz plane, x in yz plane, y in yz plane, x is constant. So xy per unit change in y, how much x is changing? X is not changing. So xy is 0. Now it becomes j plus z by y k into y. Now it becomes j plus dz by dy k into dy. Now I have to do cross product of these two. That is I plus dz by dx k dx cross product j plus dz by dy k dy. Now in that sense it becomes minus dz by dxi minus dz by dyj plus k bracket close into dx dy. This is called area vector. Calculating magnitude of this will give the actual area, where dx and dy are independent components. They vary. In a sense, if I have a sphere centered at the origin, the sphere, the sphere is centered at the origin. In that sense, if I see from the top on xy plane, it makes a circular region. So limit is a circular region on xy plane. Circular region on xy plane, that is the limit. And then magnitude of this vector, that is minus dz by dxi minus dz by dyj plus k dx dy. Whole this is called area vector. Calculating magnitude is dz by dx whole square plus dz by dy whole square plus 1 square root dx dy, where integration limit on xy plane is a circular region. Okay, in past video we have calculated the surface area. It came as 4 pi a square. Okay, how to calculate the volume of a sphere? That is the question now. Volume of a sphere. Makes sense? Volume of a sphere. This looks very small thing, but this lead to massive mathematical calculation that people can do without any error. And especially in artificial intelligence area, this multivariable, now it is multivariable, x and y, there are two independent components. Multivariable integration and differential equation and differential calculus, they are at large, and people make mistake that how I can remold our mathematical equation, that is in summation or multiplication, into calculus when it is smooth algebraic functions. Okay, in that sense I am trying to calculate volume of this sphere. So what is volume of this sphere? Can someone estimate? Now consider this is centered at the origin. Okay, consider this sphere is centered at the origin. So this is xy plane. If this is xy plane, then blue color is the origin. Okay, blue color center is the origin. Now in that sense, this is centered at the origin. Half of it is above the xy plane and half of it is below the xy plane. Top hemisphere of this sphere is above xy plane and bottom hemisphere of this sphere is below xy plane. In that sense, what is the volume of this sphere? What is the volume of this sphere? That is under question mark. What is volume of this sphere? Now, I'm asking a simple question now. How to calculate volume? What is this? Is xy plane and this is a plane on top of it. What is volume of this? Of this is, if I draw this, then it will make a cuboid. That surface on top and this vertical plane and this side vertical plane. This is x-axis, this is y-axis, and this is z-axis. In that sense, this is xz plane, this is yz plane, and this is xy plane. This is xy plane where z is 0. Now I have a surface like this. What is volume of this surface? Means volume of surface means here if I take xz plane this side, xz plane this side, yz plane this side, yz plane this side, it will make a room. It will make a room. What is the volume of that room? Make sense? Now, if I watch it closely, what is the area vector for this? Area vector into the height is the volume. Area vector into the height vector, whatever comes, calculate the magnitude of it. Means area vector dot product. Area vector is cross product of its width and length vector. If I get area vector after doing the cross product, if I do dot product with the height vector, because I cannot do cross product again. Cross product of this area vector is along the z-axis only. Cross product of this area vector is the perpendicular to the area. If I do cross product with the z vector, that is the height vector, it will come as 0. Anyway, we are trying to calculate volume. Volume is surface area vector. Volume is surface area vector. Surface area vector multiply dot product with the height. If this is the surface area and this is the xy plane, then this is the surface area vector along this direction for this surface and for this surface along this direction. Okay, whatever the surface area vector is, if I take along this direction, dot product with the z vector is will pass like this. Dot product with the z vector, height vector, will give the volume. Now, please watch carefully. This is xy plane and this is the area vector. Area vector is exactly going for this top surface. Area vector is exactly going in z direction. Now it has volume. What about volume for this? Where this whatever width we are seeing, this is negligible. This is a very thin flat surface. What is volume of this? Zero. There is no volume for this. If I go down, then it will be thin plate will come down where it is making no volume at all. Surface area is there. But if I talk about the volume, surface area into the height, surface area, whatever the air it is displacing, more or less someone can understand like this. If I take volume, then height, volume of this will be this length into this width and height. That will be the volume. Where this width is zero, means there is no volume at all. Volume of this is this width, this length and height. That is the volume. Volume of this width is zero. There is no volume at all. Why there is no volume? The surface area vector is along the x-axis. What is volume for this? If this is xy plane, no volume, zero volume. Surface area vector is along y direction. Here surface area vector is along z direction and volume is there. Because we are taking dot product while calculating the volume. That's why dot product makes sense. If surface area is exactly along x-axis, the surface is facing along x-axis, then I dot k vector, that is the height vector, is 0. If it is j vector, surface area is j vector, then height dot j vector is 0. If surface area is k vector, then height vector and surface area vector both are in k direction. Then it is 1. K dot k is 1. So directly we can multiply. Now, how I can make this volume oriented? How this can have some volume? Then little bit I have to tilt it. If I tilt, then its surface area vector from x-axis, it will start gaining k vector also. If I tilt like this, k vector is growing, I vector is decreasing, and one moment it will have only k vector and I vector is gone. So it is something like for any surface, if I have I vector, j vector, k vector, only k vector comes into the picture if I am trying to calculate volume in Cartesian coordinate system where the height vector is along k direction. Make sense? Okay, these explanations are not available in any of the book. Anyone can try. Okay, please do not mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code. Anyway, now what is our area vector? If I am calculating the volume of this sphere, then what is area vector? Multiplied by the height vector will give the volume. Okay, this is one analogy. Means if I have a area vector in simplest term multiplied by the height, we are talking about pseudo mathematics calculus, right? We will write algorithm in the simplest way. I have one area vector like this multiplied by the height, it will give the volume. What is area vector? Whatever is the area vector multiplied by dot product with the height vector will give the volume. So height vector here, if I take height vector, then what is the height? Height is zk. Z is the height. That is the dependent component on x and y. If I take a spherical coordinate. So anyway, what is pseudo formula now? Pseudo formula is area vector dot product with the height vector is the dot product with the height vector is the net volume. I believe it is all right. What is area vector? That is minus dz by dxi minus dz by dyj plus k. That is area vector dx dy. Or someone can write dx dy into minus dz by dxi plus dx dy into minus dz by dyj plus dx dyk. This is called area vector. Dot product with the zk. Now zk we will transform. What is zk? Zk is a vector and we will represent in a length vector form. If you remember, if someone remembers, then our length vector is xi plus yj. That I took out x and it becomes I plus z by xj into x. Later it becomes I plus dz by dx. I'm sorry, if it is in xz plane, then it is I plus dz by dxk into dx. Similarly, if I have a vector form of a line that is zk, z is similar to 1 into z. Or if I take out z from z, it becomes 1. So it becomes 1 into z, 1 into zk. 1 into z where z is independent component, then it will transform into calculus. Add delta z dz. 1 into dz, 1 into dz becomes 1 into dz becomes 1 into dz becomes dz. Now it becomes dzk. These explanations are very precious, amazingly precious. Now we have now area vector dot product with dzk is the net volume. Now what is area vector? Area vector is dz by dx whole square plus dz by dy whole square plus 1 square root dx dy dot product with dzk. Make sense? If someone do this dot product, I'm sorry, I should not have taken into magnitude. Let's go with the area vector. That is minus dz by dxi minus dz by dyj plus k. Okay, that is the scenario. Dx dy. This is full area vector dot product with the dzk. Now in that sense only k term will remain and iz, that is dz by dx and dz by dy will go away. What is volume now? Volume is now right now it is dx dy dz. That's it. Okay, does it make sense? That is look realistic. That volume area vector is minus dz by dxi minus dz by dyj plus k bracket close dx dy, then dot product with the height vector, that is dz k. That will k and k will remain in the dot product, I and j will go away. Now it will come as dx dy dz. Integration, now integration, all three are varying now, x, y, z. Integration for a volume. Okay, now integration has to be settled down. Now x, y, z, dx, dy, dz, and then integration. First we will settle down z because z is dependent upon x and y. What is z for a sphere? What is z? Z is square root of a square minus x square minus y square. Z is if this is centered at the origin, if this is centered at the origin, means top hemisphere of the sphere is above and bottom hemisphere is below the xy plane and blue color spot is the center, then it is centered at the origin. That is the origin, centered at the origin. Okay, means z top max z, if z is variable upon x and y, top z equation for the top is square root of, means maximum is square root of a square or z equal square root of a square minus x square minus y square. That is the top hemisphere z. Bottom hemisphere z is minus square root of a square minus x square minus y square. Top hemisphere z is square root of a square minus x square minus y square. Bottom hemisphere z is minus square root of a square minus x square. So z is minus square root of a square minus x square minus y square to square root of a square minus x square minus y square. Dz, it becomes z, and then minus 2 plus, it will become 2 into square root of a square minus x square minus y square. Okay, dx dy. I believe it is all right. That is the square root of 2 I have kept outside. The square root of a square minus x square minus y square dx dy. If I see y, then on xy plane, if I see this sphere centered at the origin, if I see from the top, on xy plane it makes a circle where y is minus a square root of a square minus x square to square root of a square minus x square. And x is actually independent minus a to a. Now someone has to settle down integration of 2 that is outside the square root of a square minus x square minus y square dy dx. Consider y equal to square root of a square minus x square sine theta. Then dy equal to square root of a square minus x square cos theta d theta. In that sense, the square root of a square minus x square minus y square, it becomes a square root of a square minus x square root of 1 minus sine square theta, cos theta. Okay, it becomes a square root of a square minus x square cos theta, and dy becomes a square root of a square minus x square cos theta d theta. Okay, it becomes now a square root of a square minus x square that I can keep outside. Now it is 2 a square root of a square minus x square cos square theta d theta integration. What is the integration of cos square theta? I believe it is theta by 2 plus sine 2 theta by 4. This is what I think. Okay, wait, what is theta? Now, if y equal to square root of a square minus x square sine theta, theta is sine inverse y by square root of a square minus x square. If y is minus square root of a square minus x square sine inverse minus 1 minus pi by 2 to pi by 2, that is the integration now. Minus pi by 2 to pi by 2, theta by 2 plus sine 2 theta by 4 minus pi by 2 to pi by 2. I believe this is the variable. Okay. Now in that sense, theta by 2, pi by 2, pi by 2, pi by 2, pi by 4, pi by 4. It will become pi by 2 only. Pi by 2 only. Sine 2 theta. Sine 2 theta, pi by 2 will become 0. For minus pi by 2 and pi by 2 0. So it will become theta by 2 means pi by 4 plus pi by 4. Pi by 2. Outside 2 is there, 2 to gone, pi. Pi we can keep outside. Now we will integrate square root of a square minus x square dx. Okay, in that sense, consider x equal to a sine theta again. Now in that sense, dx equal to a cos theta d theta. Now in that sense, square root of a square minus x square root of a square minus x square, a will come out and it becomes cos theta. A cos theta. Okay, a cos theta. This is what I think so. And then a cos theta again. Okay, a cos theta again. I'm sorry, outside was a square minus x square, not a square root of a square minus x. I'm sorry. When we were integrating dy, there was multiplication of a square root of a square minus x square and square root of a square minus x square. So outside it was 2 into a square minus x square. And then dy integration brought pi by 2. 2 to gone. Pi is outside. Now we are integrating a square minus x square dx. Now it becomes a square x minus x to the power 3 by 3. X is minus a to a. It will become 0 to a multiplied by 2. Okay, 2 I can keep outside. Now it becomes 2 pi. Outside 2 pi, and here a to the power a square x minus x square by 3, 0 to a. If I put a, it's become 2a to the power 3 by 3. Total become 4 pi a to the power 3 by 3. That is the volume of a sphere. I believe this is called pseudo mathematics. Simple with simple fundamental that area into height. We started area into height is the volume. Area vector into height vector is the volume. Then we went along. Okay, please do not mind supporting us. +91 is the India country code 9483160610 is the telephone number. +91 is the India country code 9483160610 is the telephone number.